Alrighty, so today we're going to be having a look about differentiating from first principles. So differentiating just means finding the function which tells us the slope of the function. So if f of x is our main function, f dash of x is what we call its derivative, and this function tells us the slope at x of the function f of x. So these are two functions related. So you can think of this as like a gradient function. It holds all of the gradient information in it. Alrighty, so the way to work it out, well, we take this quotient, we take the limit as h goes to 0. Remember, we're not setting it to 0. We take the limit, and we can calculate f dash of x by working out this limit expression here. This is called differentiating from first principles. So let's actually have a go through and doing it. So we've got quite a simple function, f of x equals 5x plus 6, so let's see what happens. We can't evaluate the limit yet, and the main reason we can't is because there's a h on the bottom. Currently, if we set h equal to 0, that's going to be causing an issue. So let's evaluate the top and simplify as much as we can. Alrighty, x plus h plus 6 minus, and then the original function, f of x plus 6. Alrighty, expand some brackets successfully expanded, collect like terms. The 5x cancels with the minus 5x, the 6 cancels with the minus 6, so we're just left with 5h over h. Now, we can divide h by h and cancel that out if and only if h is not equal to 0. If it was equal to 0, we wouldn't be able to do this, because 0 divided by 0, we don't actually know what that is. So now let's take the limit as h goes to 0 of, well, 5. Everything else is cancelled out. Well, there's no more h, so when we set h equal to 0, we just get 5. So f dash of x, the derivative of f, is 5. So that was for a linear function. Let's have a look doing a quadratic function instead, a little bit trickier. So the first thing I'm going to do is set up my limit. So there's my rule, substitute in f of x plus h and f of x. So this first part here is f of x plus h, and the second part is just f of x. Alrighty, expanding some brackets and simplifying. Those are all of the brackets now expanded. Now we can collect some like terms. X squared cancels with minus x squared. 3x cancels with minus 3x. Now we want to cancel that h on the bottom, so we need to factorize the top. Now we can cancel the h's if h is not equal to 0. Alrighty. And what happens now if h approaches 0? Well, we would just be left with 2x plus 3. Right? Because 2x plus 0 plus 3 is just 2x plus 3. So f dash of x is equal to 2x plus 3. So we've done a linear equation, we've done a quadratic equation. Let's try a cubic. Now for cubic equations, it's probably going to be a little bit annoying to work out f of x plus h, because it's going to be quite an annoying thing to deal with whenever you've got brackets to the power of 3. So let's work that out first. Alrighty, I'm going to be using the binomial distribution, which means using Pascal's triangle to expand this. However, of course, you could always do this using splitting the brackets into x plus h squared times x plus h. X to the power of 3 plus x to the 2h plus x to the 1h squared plus h to the 3. And then I just grab my coefficients from the appropriate line of Pascal's triangle, which in this case is 1, 3, 3, 1. 3 here, 3 here. Alrighty, all expanded. Now I can expand the next set of brackets. Alrighty, so I've now worked out what f of x plus h is. Now it's time to go and work through the limit. So let's work out the limit. So you can see I've put in my f of x plus h and my f of x. Let's expand those last set of brackets and start simplifying. You can see that the minus 2x cubed is going to cancel with the plus 2x cubed. Alrighty, now that I've simplified the top, factorize the top, and get ready to cancel. You only ever want to take out a factor of h, just because that's what's going to cancel with what's on the bottom. assuming h isn't equal to 0. Now all we need to do is take the limit. We've got minus 6x squared minus 6xh minus 2h squared. Well, as h goes to 0, this term's going to disappear, and so is this term. So the whole thing's going to be equal to 0. So the limit is just going to be equal to minus 6x squared. And that is our f dash of x. So if the function is one thing, there's the derivative of the function. I want to do just a quick recap on what we've done. Alrighty, so we did 3 derivatives in this quick lesson. And I just want to show what they look like right next to each other to see if you can see the pattern that's going on. So if f of x is equal to 5x plus 6, well, f dash of x is equal to 5. If f of x is equal to x squared plus 3x, then f dash of x is equal to 2x plus 3. And for the last one, if f of x is equal to minus 2x to the 3, then f dash of x is equal to minus 6x squared. The first one should be kind of obvious just because if you think about what is the gradient, the derivative of a line? Well, the gradient of the line is entirely defined by the gradient term. It's the slope of the line. So it makes sense that the function would just be equal to 5. Because it doesn't matter where you are on this line, it's going to be straight. The others I'll leave as things for you to think about. See if you can see any patterns. Alrighty, see you in the next one. Bye.